Alright, student, back to our Cook's Radio again. Today is the Monday, 25th of March, 2019. What I'm going to talk today is about our IC555 as the clock, or IC555 timer. Let's start with the question about how our IC555 generate 1 Hz pulse frequency. Okay, IC555 is the pulse generator. You can create a frequency at 1 Hz, and then also this the popular IC555 timer can be connected as the stable multivibrator and also a monostable vibrator. For a stable multivibrator, the output pulse can be specified or can visual at the LED. Sometimes we call a stable multivibrator as the free runner. Because there's no trigger pulse or trigger signal to trigger output switch from high to low or low to high, or from 1 to be as the digital logic from 1 to be 0 or 0 to be 1. This will generate the rectangular wave or pulse, which is different from a monostable multivibrator, because the circuit don't need trigger or external trigger to change or switch the output status to be 1 to 0 or 0 to 1, or from high to low or low high. So that's why we call this one as the free running. And the circuit can be used for the application that need a clock pulse. The next step, we take a look at the data sheet of IC555. A stable multivibrator can generate output pulse or timer by external resistor and external capacitor to the circuit. The timer circuit, the basic timer circuit IC555, the duration of the output to be high or low, and specified by two external resistor and 1 external capacitor. Clock is just a rectangular pulse of waveform that give logic status high or 1, or logic status low or 0, alternatively. Each high and low will generate a clock cycle that have a frequency and duty cycle as specified. For the frequency is the cycle, the complete cycle in 1 second, and duty cycle is the ratio of the duration of status high, or 1, divided by the period of the duty cycle, as show you in the figure. Okay, so this is your duty cycle, that's equal to the ratio of T high divided by T cycle, and this is your T cycle that include T high and T low. Okay, and okay, let's you can set IC555 to work as at the specified frequency or required frequency by using external and external resistor and external capacitor, as I mentioned earlier. So according to equation, the frequency is going to be 1.55 divided by R1 plus 2R2 and then multiply by C, and R1 plus R2 you can say that this is the total resistors. In addition, IC555 can generate the waveform that have a duty cycle smaller than 50%, and your duty cycle can be calculated from R1 plus R2 multiplied by 100. That's in percent, right? Because you multiply by 100 and divided by R1 plus 2R2. And then, as I mentioned earlier, duty cycle is the ratio of the period when the output is 1 divided by the period of the cycle. Next, I'll explain how the circuit works. From the circuit, okay, this is from P-Spice. This is the 8 pins IC555, and I use this one as the 555D. You can see that you have like 8 pins. Start from pin 1, that's ground, and pin 2 is trigger, with 3 is the V out, 4 is reset, 5 is control pin, 6 is threshold pin, 7 is discharge pin, and the last one is 8 is the supply voltage pin or VCC. This is the way I connect as the Monostable Multivibrator. Okay, so that's why you need the trigger pulse to change your output to be 1 to 0 or 0 to 1 or high to low or low to high. How it work? Capacitor C1 will start charging VCC through resistor R1 and R2, which is the potentiometer or variable resistor. And then the time constant to charge is the total resistance multiplied by capacitance, and total resistance is of course become R1 plus the R2. Finally, the threshold voltage will increase more than 2 by 3 VCC or supply voltage, and then cause the comparators to have output high, and will trigger flip-flop to have output to be high, and the timer output will be low when Q is high, and then transistor will discharge and the pin 7 go to ground for the capacitor C1 to discharge through resistor R2 or potentiometer or variable resistor with the time constant R2 multiplied by C. Okay, so let's get back to the data sheet of our IC555 to get a better picture. So this is the internal of IC555. You can see that this is, you have a comparator and then connected to a flip-flop, and the output of flip-flop go to the output stage, and then that's what you can have your output. And also you have a internal transistor, both PNP and NPN, and you also have a extra comparator. So basically for inside IC555 you have 2 comparators. Okay, next, by discharge of capacitor, the trigger voltage at the inverting input of comparator number 2 we were decreasing, and then when the input voltage is the output voltage is decreasing less than 1 by 3 VCC or the supply voltage, the output of comparator number 2 we have the logic high or 1 and then reset flip-flop, and that caused the output of the timer to be high. And then you have auto transition of the output from low to be high, and then turn back to be low again, and then this repeat the duty cycle, and that's how the circuit work. Next one is the let's talk about the difference between a stable multivibrator and monostable multivibrator. For the multivibrator is the circuit does have two stable states. Each state that's stable shown by the voltage, for example 0 volt, and which we define as the digital logic low rate, or 0, and then 5 volts, and define as the digital logic is the high or 1. A stable multivibrator is that the output will jump between two states that are stable continuously, and then also known as the oscillator, and uses the clock to drive microprocessor circuit sorry, etc. For monostable multivibrator is that when the trigger change in one period and then return to the base state. For example, after the trigger, the voltage will switch from 0 volt to 5 volt, and stay there for a period of time, and then return to 0 voltage again. And that period can be in the range of nanosecond to seconds, depending on applications, and then can be used in logic circuit to prevent competition or conditions. For example, like to turn on the lamp for a period of time. For bistable, there we have two stable states. When there's the trigger, we will switch from one state to the other state, and then latch until there will be another trigger is coming in, and then return to the original state. For example, the output state will be at 0 volt or digital logic low to 5 volt or digital logic high when there's the trigger, and then the next trigger will return the logic state to be 0, or that's we call latch. There are so many applications, from integrated circuit to the circuit that's composed of discrete components. For example, discrete transistor or resistor, capacitor. And then let's focus on a monostable mode again. IC555 timer that's working in monostable mode, or one shot. Starting from the external capacitor that connected to the circuit is still discharging through a transistor, and the trigger, the negative trigger that have the voltage less than 1/3 VCC or supply voltage will be used at the pin number 2, and then start flip-flop to discharge very fast and drive output to be high. This voltage will increasing across the capacitor, and then the duration of the time can be shown by the equation t, or time constant, equal to 1.1 Ra multiplied by C. And then the capacitor will be fully charged. And after this, when the voltage across the capacitor will finally reach what? 2/3 VCC, or the supply voltage. After that, flip-flop will be reset by comparator, the internal comparator of the IC, as I show you just right here. Okay, you have the comparator here, and then there will be discharge immediately, and then the output will change the state to be the logic state, low or 0. Okay, and that's when we talk about monostable mode. And the other one is the astable mode. The very important configuration in the mode of stable mode is that you connect pin number 2 and pin number 3 of IC555 together, and then the circuit will work as the free run, as the activate the frequency by self activation. And then also we have to talk about the charging of the capacitor. The external timers happen because the external resistor Ra over Rb, and then there will be discharging complete through Rb. So the duty cycle of the circuit will be very accurate by adjusting the ratio of Ra over Rb. At this point, the capacitor will be charged and discharged between the voltage of 1/3 and 2/3 VCC, or the supply voltage. During this time, there is very good control and no effect from the voltage variation. For the upper working mode of IC555, specify that chip is the time duration generator. Does vary a lot. By changing the time duration, will make the circuit that use the chip or IC555 for different applications. And then I will talk about this one later on, about the IC555 timer applications. Now let's get back to the data sheet that I also downloaded. Okay, here I will explain to you about for the data sheet. Okay, this is your LM555 timer data sheet that I carried from TI, or Texas Instrument. Download from the net. Okay, this is like TI's. And this is the features. Can replace the directory, or directory replace the SE555 and NE555. Can specify the time duration in microseconds to hours. Can work in both Astable and Monostable Multivibrator. And duty cycle adjustable. the output the current output currents 200 milliamp, and then compatible, or the output is compatible with TTL, have a stability with the temperature more than 0.005% to 1 degree, and output in on and off states in form of VSSOP package, a very small package with 8 pins. Applications: time accuracy, generate pulse, sequential timing, time delay, pulse width modulation, pulse position modulation, linear ramp generator. Details: RM555 is the device that have a very high stability to generate time delays or oscillations. The external terminal is for triggering or resetting as the required. For the time delay mode, can be controlled the time with very high accuracy by external resistor and external capacitor. For working as the stable oscillator, the frequency and duty cycle as the free timer can be controlled with high accuracy by 2 external resistor and 1 external capacitor. And the circuit can be triggered or reset by the following waveforms, and the output can supply the current up to 200 milliamps, or can drive also the TTL circuit. Configurations. Okay, as mentioned earlier, you can replace directly for SE555 and NE555. This LM555 timer can replace the SE555 and NE555 directly because they have exactly the pins layout. And RM55 is in the PDIP or dual line package, SORP small outlier IC or VSSOP small outlier package with 8 pins package. 2 can do the timing from microsecond to hours. RM55 has ability does have a parameter to define the time from microsecond to hours, and also the delay time of the system can be specified by the time constant or the product of R and C, and this can be used as the monostable or Astable Multivibrator mode. Number 3 can work in both stable and monostable multivibrator mode. RM55 can work in both stable and monostable mode, depend on the requirement of application. For the monostable mode, the RM555 timer used as the pulse generator for one shot, and pulse start when the RM555 timer receives the signal at the input when the trigger is decreasing or lower than 1/3 of VCC or the power supply. And also the width of the pulse will be defined as the time constant or the product of R and C, and then the output pulse will end when the voltage across capacitor is equal to 2 over 3 of supply voltage, and also the width of the output pulse can be extend or narrowing by adjust the value of R and C. The next one is the Astable Multivibrator mode, or sometimes we call free running. IC555 timer can be used as an oscillator, and then it can generate the rectangular pulse, the continuous rectangular pulse, and with the frequency as divided, and the frequency of pulse group is depend on the external resistor RA, RB, and external capacitor C. Now our monostable mode. In this mode, timers will work as one shot. The external capacitor will starting from discharging by internal transistor, and then when the use of the negative trigger pulse less than 1 over 3 VCC, to the pin 2 will reset the flip-flop, and both will short circuit through capacitor and drive output to be digital logic high. The voltage across the capacitor will increase as the exponential with the period t equal to 1 by 1 RA multiplied by C. At the end, when the voltage is equal to 2 over 3 VCC, and then the comparator will reset flip-flop, and then will discharge and drive output to digital logic to be low, because the charge level and threshold voltage of comparator, all of them will be direct proportional to the supply voltage. This result in the time duration is not depend on the supply voltage that's specified in the data sheet. When the time duration during the time duration when output is high, the next job of the trigger pulse will not affect the circuit as long as the trigger input is returned to high at least in 10 microseconds before finish the time duration. However, we can reset the circuit during this time by using the negative pulse to reset terminal, reset or pin 4, as in the pins diagram, and output still stay low until there's another trigger pulse coming in. Whenever we don't use the reset function, recommend to connect reset set pin and VCC to avoid the fault triggering. Number 5 is the Astable Multivibrator mode. Okay, this one is actually this is the way to connect is the work as the Monostable Multivibrator. Sorry that I don't have the circuit just for this one. For this one. But for Astable, just take a look quick. Just connect the pin number 2 and pin number 6 together. View cell trigger and free run as the multivibrator. And external capacitor will charge through RA and RB and discharge through RB. So the duty cycle will be defined with very high accuracy by the ratio of these two resistors. The capacitor will charge and discharge between the voltage of 1/3 VCC to 2/3 VCC or supply voltage, as well as in the mode trigger. The duration of the charging and discharging. So the frequency is not depend on the supply voltage. Here is the time, the charging time, or when the output time, T1 equal to 0.693 multiplied by RA plus RB, which is the total resistance, and then multiplied by C, capacitance, and then the discharge time when the output is low, T2 equal to 0.693 RB multiplied by C. So the total period is the T1 plus T2, that's equal to 0.693 multiplied by RA plus 2RB. This is total resistance, and then multiplied by capacitance. And then the oscillation frequency is simply become 1 over period, or 1 over T, and thus give you 1.44 divided by RA plus 2RB, and then multiplied by C. And then the time duration can be calculated from RB divided by RA plus 2RB. Next, the application of our RM555 timer. There are so many applications, but typically we'll use the RM555 timer as the monostable. For the typical application of RM555 timer in the monostable mode is to turn on and off LED in the certain time. There is the push button for trigger to keep a pulse to be high for the output, and then when feed the low pulse to trigger can change for specific applications. Let's take a look at the RM555 that flash or turn on and off LED in the monostable mode. The requirement for the design is that you have to calculate the time duration that output is still high, and the time duration is dependent on the external resistor and external capacitor. That can be calculated from this equation. T equal to 1.1 multiplied by R multiplied by C second. Okay, I think I will discuss about the application of IC555 later on, because this one I don't have the circuit diagram yet for IC555. Okay, I will talk about it later on. Okay, thank you. Bye.